We are going to talk about the fourth dimension. What's the problem with our intentions to define the fourth dimension? The stone that we are stumbling upon in this intention is that we are trying to stretch our space in some direction so we can get the fourth dimension, but obviously we can't. We'll start with terms that we are all familiar with, and we'll start with the zeroth dimension. Here we have a point, and a point has no dimensions. If we put points one next to the other in one direction, we get a line. The line is in the first dimension, and on a line we can measure the distance between 2 points. We can measure a length, meaning we have only one dimension to measure on a line. Now we get to the second dimension. Similar as with how we got to the line, we put lines one next to other, and we get a plane. A plane is also defined with two lines, with two intersecting lines, and it's important to remember that intersection between two lines is a point. Okay, now a second dimension, as the name says, we can measure two dimensions, length and width, and we will take a simple shape, a square. In the second dimension we have square, and we can measure its length and width. And now, what happens if we get another plane at an angle to the first plane? As we got a line at an angle with another line, we got intersecting lines, and now we get intersecting planes. Two intersecting planes define the third dimension, and now to explain some aspects of the second dimension, of the third dimension, and we can use that in defining the fourth dimension, we will use Carl Sagan's Flatlander. It's a being that can only perceive length and width. It moves in its own plane. I suppose you know that. You have seen some videos of Carl Sagan. Now, this Flatlander, we suppose he is walking on his plane, and at the moment he gets to the line that is an intersection between his plane, the first plane, and a plane that is at an angle with his plane. What will happen if this Flatlander accidentally, or maybe not, walking on the line, he continues his walking not on his plane but on the other plane that is at an angle to the first plane. Probably he won't even notice the difference, for in his plane there is XY coordinate system. We can get XY coordinate system, so we can define the points that he reaches during his movement. And now, if he continues moving on the other plane, for him it is the same coordinate system, XY. But for us as three-dimensional beings, if we look at him, we'll see that he is now moving in another plane, and here we have X1 and Y1 coordinates for the points that he has reached. Now we will use this to define in the fourth dimension how would we feel if we move somewhere in the fourth dimension. First, we said that two intersecting planes define the third dimension, and we have here height. But we know that the three dimension is in space, and we have coordinate systems x, y, and z. What happens if we have another space where we can define coordinate system x1, y1, z1, and it is at an angle to our space? The intersection between these two spaces would be a plane. And now, as the flatlander walking in the third dimension, for him only in the second, a three-dimensional being as us would move in his space, and if he accidentally goes through the plane that is the intersection between his space and some other space that is at angle to his space, he will continue moving, probably not even recognizing that there is some difference. But a fourth dimensional being could see that now he is moving in some other direction. This is in analogy with the third dimension. In the second dimension, we have a simple shape, square, and now if that square, if we get the square, it is formed of segments of lines that are segments that lay in different lines, on 4 different lines. If we want to construct a cube, we take 6 squares, but they all lay on different planes, on 6 different planes. In analogy with this, if we want to construct a 4-dimensional object, we need cubes that lay in different spaces. Imagine now as the 3-dimensional being comes to the plane that is intersection between 2 spaces. We can say that this plane is somehow a portal for moving from one space to the other. Similar, we can say for the line in the third dimension, a line that is the intersection between 2 planes. For the flatlander, it could be a portal for moving from one plane in the other. If the plane is the intersection between 2 spaces, and if we put a square next to that plane, in analogy as before, and as we said that if we want to construct a 4-dimensional object, we will need cubes. If we put a cube, before I said the square mistake, if we put a cube next to the intersecting plane, this square that lays on the plane is a joint side of the cube with other cube that is in another space. Meaning we have no idea where that space is, the other space, but we know that we know one of its planes, one plane of it. We can conclude that the other cube that is joined with the cube in our space is somewhere in our cube or out of our cube. So I can conclude that the fourth dimension is in and out. But now, having so many spaces, different spaces, a lot of questions raised. As for example, many of us have some encounters, maybe NLO objects, some other objects, or even shadowy things walking somewhere. Now it's easier to explain all of this. And also we can say, we can ask another question: what is does time exist in this fourth dimension? Meaning, with so much spaces, what's happening? And even another question: are we, as three-dimensional beings or objects in the third dimension, are we a part of a four-dimensional being and having other bodies in the other spaces? If you are interested to hear all of my explaining of and answering of these questions, you can follow me. Bye for now.